Okay, so today we're gonna do 3.6. The chain rule. So we are using this rule for composite function, okay? So composite function, most of a function is composite function if x, this is not x squared, x cubed, and so on. It's not sine x, it's not cosine x, the trigonometric function, right? Then other than that, everything is a composite function, like a square root with x, right? And also sine x to the third, or cube root 3 x to the fourth plus 1, right? So we are using that. Rule. Chain rule. Let me write down chain rule. So, what's going on? Okay. The chain rule. We know f and g is a function, and let's say that, let me just read, for all x in domain of g, and g is differentiable at x, f is differentiable at g over x, then we have, this is a composite function, right? So look, oops. F compose with g of x, right? Then we can denote this one this way, f of g of x, right? Okay, then if we derivative the function, okay, then there is f prime of g of x, right? Then what is the inside? G, right? So we do g prime of x. In other words, we have another notation. If, let me write down, alternatively, if y is a function of u and u is a function of x, then dy over dx equal to dy over, look, dx. Let me write down this way. Okay, dy over dx. Okay, then I'm gonna insert du. Du here, du here. Okay, so we call this is Leibniz. Hard to pronounce. Let me write down the name first. We're gonna do that this one. Leibniz notation. Okay. let me erase this one. So remember, if we have a composite function, we want a derivative, okay? Then f prime of g of x and g prime of x, all right? So let me erase. So we're gonna do lots of practice. One more, one more rules. So power rule in the composite function. Okay, so if we have g of x to the n, right? Then we derivative of g of x to the n power. Then we are using power rule. So what do you get this one? Power rule.
N times g of x to the power of n minus 1.
Yeah. Good, very good. Okay. Now, there's a g of x, right? So we're going to do g prime of x for the composite function, okay? Before, we had just one single polynomial without that, okay? But this time, we have a composite function. So we do derivative of what is inside, okay? All right, so let us do this one first. Find the derivative of h of x equal to 1 over 3x squared plus 1 to the second power, okay? So we had experienced this one. If numerator is constant, then we can just using negative power, right? So let us rewrite this one. It's 3x squared plus 1 to the negative 2, right? Okay, now we're gonna use power rule, okay? So we drop the power reduced by 1 over the power, okay? So let us say that h prime of x, okay? Drop the power and reduce by 1. So let me just write down this way. Now, where's the x? Where's the x? Original problem. Where is the x?
3x squared plus 1.
Yeah, x is inside, right? So we're gonna derivative whatever inside again. Make sense? That's the chain rule. Okay. All right, so then let us do that. Negative 2, 3x squared plus 1. And what's the derivative? 3x squared plus 1.
6x.
Good. 6x. All right, and that is just, oops, I forgot. That's why try to multiply. Hold on 1 second. Negative 12x, and then we can write down that is denominator, right? which is 3x squared plus 1 cube, right? Number 2, let's see. Same h of x equal to sine cube x. So once again, this means same as, we should know that, right? This means sine x to the third power. Okay. Now, we're going to use power rule. Drop the power. Then reduce by 1 is 2, right? Now, where's the x?
It's with the sign inside.
Yeah, so we cannot just say x because x is by itself, right? So we do derivative sine x. Because we just did only using power rule, right? Make sense? All right, so then we have 3 sine square x. What's the derivative of sine x?
Cosine x.
Cosine x. Thank you. Okay, this is the answer. Let me erase this one. Find the equation of tangent line to the graph of this square at x equal to 2. So this one, we did several problems, right? Okay. So this one we can rewrite with the power. So that is -5 to the -2, okay? Now, derivative, we're gonna find the slope of a tangent line first. Power rule first.
-2 times the quantity 3x minus 5 to the -2 minus 1 power.
Then whatever inside, x is inside, right? So we do derivative. Okay, then what do you get? Then we derivative 3x minus 5.
3.
3. So we have -6 over and 3x minus 5 to the third power, right? Okay, then when x equal to 2, so h prime over 2, can you please calculate this one? 3 times 2. minus 5 to the third power. Can you please give it to me answer?
I think it's -6.
Negative
Six.
6. Thank you. All right, then we have a slope, right? Then when x equal to 2, what do you get? H over 2. So 1 over, can you please calculate?
It's 1.
It's 1. Okay. Thank you. Minus 5. Second power, it's 1. Okay. Then there is the 2 and 1 or a pair that is corresponding x, y, right? So basically x sub 1, y sub 1. So we're going to use a Point's law formula, right? So y minus y sub 1 equal to slope of tangent line. Or we can use f of h prime of 2, right? And x minus x sub 1. So y minus 1 equal to, the slope is negative 6, x minus x sub 1, which is 2. Then y minus 1 equal to negative 6x plus 12. What do you get this one? Plus 13? This is equation of tangent line there. You want me to show you decimals? Is okay, or do you want me to show in the decimals?
You don't have to show us. It's fine.
Okay, so we had the last time, right?
Yeah.
Okay, good. All right. Let me erase.
Yes.
Okay, thank you. All right. 3.6. Number. I'm losing the number. Derivative of h of x equal to cos. How about sine? Doesn't matter, cosine, sine. Huh? How about tangent? Cotangent, cotangent, cotangent. Cotangent. 5x squared. Okay, so we're gonna find the derivative of the function. So we have a power, it's not the outside, right? Can you see that? All right, then we're gonna derivative cotangent first. So what's derivative of cotangent?
Negative cosecant squared.
So negative cosecant square, and then we just follow exactly, right? Whatever they have. Now, where is the x? There is the x, right? So we're gonna derivative. What is the inside? Okay. Then, Turo, can you please answer the chat? Otherwise, I can answer that on is after lecture. All right, so we do derivative 5x squared. Then negative cosecant square 5x squared. What's the derivative of 5x squared?
10x.
10x. Okay, so let me write down in front so that so that we don't multiply 5x squared and 10x. Okay. Oops. So negative 10x. Okay. So negative 10x cosecant square and 5x squared. 1, 2, 3, 4. I'm not sure, but number 4. Number 5. Let's see.
So for like these type of problems, you don't want us to like expand them, right? It's just
There's nothing we can expand. This is
yeah,
a
but
composite function, right?
yeah,
Cosecant square 5x squared.
I know some other ones like on the homework. There were some.
So they say that don't expand, right?
Some did, some didn't. But
Yeah.
on the test, like
Some did, then that is complicated.
yeah.
Some didn't, then probably a little bit not less complicated. So you
Okay.
can make
So,
simplify as much you can. All right.
okay. So like on the test, would we like for expanding, we probably wouldn't have to do that, right?
That's correct. Whatever the instructions say that. Okay.
Okay. Thank you.
You're welcome. So here we make a derivative. Can you recognize what kind of rule we have to use, right? So what we have to start? What's derivative?
Of secant and then remove the 4x to the 5th power plus 2x.
Okay, so we're gonna derivative secant first. So what's the
Yes.
derivative of secant?
Secant x tangent x.
Secant x 10x, right? But in this case, x replace the whatever inside. Okay. So 4x to the 5th power plus 2x. Then tangent x, which is whatever inside, this composite function. Okay, now we're not done yet because where is the x, right? So we're gonna derivative. So we do d over dx means derivative with respect to x. So since we learn only one variable right now, so 4x to the 5th power plus 2x. Okay. I have time today, so let me write down. And what's the derivative of 4x to the 5th power plus 2x?
20x to the 4th power plus 2.
So 20x to the 4th power plus 2. Okay, so don't multiply with 4x to the 5th power plus 2x. Okay, so that's why I'm writing here with a bracket. Should I put that in front? So let's see. 20x to the 4th power plus 2. Oops. All right. So look, by previous example, so cotangent and secant, whatever have inside the composite function, we make a chain rule, right? So let me write down, would you like to prefer this one or this one? Let me write down two ways, okay? There's two ways we can write it down. The formula, would you like prefer g of x, g prime of x? Would you like to prefer this way, or would you like to prefer cosine u du over dx? Which one is you like? This one, number one or number two? Because I don't want to write down twice. It's the same, but different expression. Which one? Number one, number two?
I think I like one better.
One better? Okay. Let me write down one, like one, okay? Let me write this one. 3.6 kilowatt. We do one section every day. All right, so theorem 3.10, channel for trigonometry. So they're not really formula because g of x and then g prime of x. Trigonometric functions. G over dx, sine g over x. And we know this is the cosine g over x. Then whatever inside, we are using chain rule, so g prime of x, right? What about the cosine g over x? What's the derivative of cosine x? So I'm doing repeat this one again from the last section, right? So that you can remember, all right?
It's negative sine of x.
Fine, good. G over x, then g prime over x, okay? Now, 10 g over x. With derivative of a tangent, what do you get?
Secant squared x.
Secant g over x, right? Then we do whatever inside g prime over x. Now, cotangent g over x. What's the derivative of a cotangent?
Negative cosecant squared.
Negative cosecant square x, so g over x in this case. Now, g prime of x, right? Two more, right? Secant g over x. With derivative secant, what do you get?
Secant x tangent x.
Yeah, secant x, so secant g over x. Then tan g over x. tan g of x. Okay, now g prime of x. Okay, last one, cosecant g of x. With derivative cosecant x.
Negative cosecant x, cotangent x.
So cosecant x means cosecant g of x in this case, and cotangent x. So g of x. Now we do g prime of x. Okay. So basically same as last time, right? Last section about the derivative of trigonometric functions. So just using chain rule, whatever inside, we do derivative again. All right? Yeah. So I'm gonna erase this one. I see that someone who's really writing really seriously. Take a picture. Well, this one is in your book, okay? You have a free book. Okay. Six. The letter, because I'm using h of x all the time. Okay. Or p of x. 2x plus 1 to the 5th power, 3x minus 2 to the 7th power. All right. How we gonna derivative this one? P prime of x.
Do we have to do the chain rule and the product rule?
Product rule first, right? So chain rule always last. So product rule, very good. So this will be f. This is g. So we do f prime g plus f g prime, right? Okay. All right. So f prime. So how do we do?
Would it be just 5 and then parentheses 2x plus 1 to the 4th power? Would we just do that without taking out what's in the middle?
Very good. So 5 2x plus 1 to the 4th power. Now she said that, oh, we're going to do chain rule again, right? We're not done yet, right? There is f prime completely, okay? Now we do g. G is this one. Then plus f, which is 2x minus 1 to the 5th power, g prime.
Seven times 103x minus 2 to the 6th power.
Sorry, no space. Very good. Okay. Now, okay, derivative. With derivative 2x plus 1, what do you get?
It's just 2.
Just 2. Okay. Now we have a 3x minus 2 to the 7 power and plus just rewriting. 7 should be in front and doesn't look like a 5. It's a 5. Then we have 3x minus 2 to the 6th power. Now, with derivative 3x minus 2, what do you get?
3.
3? Okay. Now we have 10 there. 2x plus 1 to the 4th power. 3x minus 2 to the 7th power plus 21 and 2x. Wait a minute, why I keep the sign changing? It's plus 1, huh? Plus 1 and plus 1. So plus 1 to the 5th power and 3x minus 2 to the 6th power. Okay? So let us just leave like this. Some book indicate that just a factoring out, but all right. Okay, so more advanced. Let us do 10 or 7x squared plus 1. Okay, once again, if we see this one, this is the same as 10. 7x squared plus 1 to the 4th power. Okay, and we do derivative k prime of x, what do you get? Well, we have to start. No idea?
Would you just take the 4 and put it down and then do 4 tangent 7x squared plus 1 to the 3rd power?
Good. We're gonna deal with the power first, right? So 4, 10, and 7x squared plus 1 to the 3rd power. Same as it like that, right? Okay. Now, we did not derivative tangent, right? So we do derivative, whatever inside the bracket, because we just dealt with power, right? So we do 10, 7x squared plus 1. Now, let us just rewrite. What's the derivative? 10, 7x squared plus 1. So trick.
Tan 7x squared plus 1 secant? No, it's secant squared.
Squared, okay?
Yeah.
So squared, 2x plus 1, okay? Now, we have not derivative the variable x yet, right? So we're gonna do that. So this is a chain rule over chain rule, right? So composite of composite function. So let's rewrite. And with derivative of 7x squared plus 1,
14.
what? 14. So 14x, right? So 14 times 4, what do you get? So let us write down in front. 14 times 4.
56.
56x. 10 cube. 7x to the second power plus 1. And secant squared. 7x squared plus 1. Okay? That is the final answer. Okay, let me erase this one. Or I'm not sure what number is this one. Thank you. -4 cosine sine x. Okay, so with derivative, I did. Okay, thank you. How do we start?
Take the derivative of the outside.
What is that?
4 sine with sine of x still inside of it.
So basically we need a derivative cosine first, right?
Yeah.
Okay, the coefficient, we keep the coefficient, right? Then what's the derivative of cosine?
Negative sine.
Negative sign, so it's a positive. It will be positive, right? Positive 4 sine. Now whatever inside, right? Then derivative with derivative, composite function, chain rule. So inside the sine x. Okay. And what do you get this one?
Sine x.
4 sine of sine x. Then cosine x. Good. Okay. Okay, number 8. All right. Next. -2 sine of cosine of x cubed. G prime of x. So same, we make a derivative of sine x, right? Sine whatever. So what's derivative of sine?
Cosine.
Cosine, right? But then we have a coefficient, so we keep the coefficient. So -2 cosine. Now we just rewrite this one. All right. Now we're gonna make a chain rule, whatever inside. So cosine x cube what's the derivative of cosine x? Derivative of cosine?
Negative sign.
Negative sign, whatever inside. Okay. Now we're not done yet. We have not derivative using chain rule for the variable x. So we do derivative whatever x cube. Okay. So then we have -2 cosine of x cube. And negative, so negative is positive. Then we have sine x cube. Now, what's the derivative of x cube?
3x squared.
3x squared. So let me write down 3x squared here. 3x squared in front, okay? Then let us make 3 times 2, which is 6x squared. Then cosine of x cube. Then times the sine x cube. All right. This is the final answer. Is it hard? This is so much fun, right? What do you think? So let's talk about the notation. Leibniz, right? Is it correct pronunciation? Leibniz notation. Then we are done for today. Let me erase this one. So we introduced this one earlier. If y is a function of u and u is a function of x, then we have dy over dx. I introduce you like this, right? So dy over dx, right? Then it's the same as du there, right? Makes sense, right? Okay. So basically that is simplified and this one, all right? Now, how do I use this one? This one is the trig is better. Fraction is better, trig is better. Let us do one problem. Find the derivative of y equal to x over 3x plus 2 to the 5th power. All right. So like this, let u equal to whatever inside, okay? So inside is x over 3x plus 2. Now we say that then, look, since we said that u equal to whatever inside, which is x over 3x plus 2, then we can say that y equal to u to the 5th power. Fifth power, right? Make sense? Okay. Then look, we have dy over dx, du over dy over du. Okay, that means we're looking at this one with derivative with respect to u. That means, okay, du over du. I'm sorry, why I kept saying the du. dy over du. Okay. So what do you get this one?
The power rule, so 5u to the fourth power.
Good. Okay. Now, we need to have du over dx. We're looking at this one. And then we do derivative with respect to x. Can you see that? So what do you get? This one, du over dx. Oh, this is a little bit complicated. So how do we derivative this one? It's not that like that, right? So how do we derivative this one?
Do you use the quotient rule?
Yes, we are using quotient rule. So f over g. So f prime g minus f g prime over g squared. Okay, let's do that. All right, so f prime, which is f prime. What do you get? Good, 1. And g, right? So we have experience, so I don't write down 1. G minus f, g prime, what do you get? G prime. Hello, g prime 3, right? And over g squared, which is 3x plus 2 squared, okay? Now, that's it. Let us simplify a little bit, okay? So, little bit, as much we can, basically. So, du over d, I'm sorry, why I kept saying du? dy over du, dy over du. Ah, this is why my mistake here. So should be, this is y over, right? So dy over du, right? Oh my goodness. I made a mistake there, dy over du. Dy over du, which is 5 u to the 4th power, and du over dx, which is negative 3x over 3x plus 2 quantity squared, right? Okay, now the variable is not matched, right? So we're gonna change back, substitute back. So this will be 5. What was u? U was the x over 3x plus 2 to the 4th power. Okay. Now negative 3 and times 5, which is negative 15. So let us make a negative 15 there. Then x over, we have 3x plus 2 to the 2nd power, right? Is it okay? All right then. Did I make
Sorry, is it
I made a mistake.
4 instead of 3x?
It's 2,
Yeah,
right?
sorry. Yeah.
Yeah, I just see that right now. So look here, right? I made a mistake here as well. This one. It's a 2, not the 3. I saw that, right? Only 2 there. Why I kept the -3 from there. So this is 2. Sorry about that. So it will be +10. +10. Without x. I know you
Okay.
want to say that, right? Without x. So 10. Thank you for catching up. All right then, we don't need the x there. Okay, so it's 1. Okay, then look, exponent, we can do that, right? So we have, this will be, look, 10 x to the 4th power. Then bottom, 3x plus 2 to the 4th power, and then there's 2, so we added that, so which is 6, right? Then we are done. This is the final answer. Is it same answer? Okay. All right. Let me erase.